Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on antenna. This video, I'm going to explain what is actually dipole antenna to the characteristics of the dipole antenna. Next, I'm going to explain exactly how this dipole antenna actually work from the source, how it create the E field and also the magnetic field, and then finally release the electromagnetic wave into the air. So basically all this will be the objective of this video. This video, in fact, I will use some form of animation in order for you to understand these challenging topics. This is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, it's free and it's just a few seconds. Help me. Press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let me firstly define what is actually a dipole antenna. So in fact, dipole antenna is one of the simplest. So from here you can see that this is actually a dipole antenna, and it basically just need to have two conducting material in order to become a dipole antenna. So therefore, because of the simplicity, it is also the most widely used type of antenna for radio communication. Like I mentioned earlier on, they basically consist of two conductive elements, as you can see from here. So basically, these two conductive elements, they are usually metal rod, or even for some case, even wire can make up of this conducting element. So basically, this part here will be connected to either the transmitter or receiver. Next, these two parts, okay, so basically these are the two parts. They actually form a straight line, as you can see from here, and they actually radiate electromagnetic wave when current actually flow through them. I will go into more detailed discussion on this later on. Let me explain the basic structure of a typical dipole antenna. So the most common dipole antenna will be the half of wavelength dipole antenna. So basically with the length, the total length of this dipole antenna, half of wavelength. So from here, we can see that there are actually two equal length of metal conductor, and hence one metal conductor will have the length of quarter wavelength. So basically this is actually the structure of dipole antenna. A feed point, okay, basically will be at the middle, okay, where the transmission line actually connect. So typically the transmission line will be the coaxial cable. This portion here, they will be connected either to the transmitter or the receiver. Each side actually act as one pole of the antenna, and because we have two poles, and therefore this is why we call this dipole antenna. When radio frequency current actually flow into the antenna, for example, for this case here, when current actually flow into the conducting material, it actually create an oscillating electric and magnetic field, which thereafter radiate outward as radio wave actually release into the air. Like I mentioned, I will go into more detailed discussion later on. Next, let me share with you how can you actually compute the length of this conducting material. Like I mentioned earlier on, the most common dipole antenna will be the half wavelength antenna, as you can see from this diagram here. So basically, this will be the total antenna length. So this is actually the size of the antenna, which is half of wavelength, or in practical, in fact, we will use this equation to estimate the overall length of the antenna. So 150 divided by frequency in megahertz. Basically, this SI unit will be in meter. Let me give you an example to understand this. For example, okay, this is actually for FM radio, which is at 100 megahertz. So from this equation here, you can see 150 divided by 100. Okay, we don't want to enter this times 10 to the power 6. We just want to enter the numeric value of 100 in terms of megahertz. So therefore, we actually get that the length of the antenna will be around 1.5 meter. So therefore, like I mentioned earlier on, because they actually contain two equal conducting material. So therefore, each side should be 0.75 meter. So basically with 0.75 meter here and with another 0.75 meter over here, this will actually create a dipole antenna. Let me explain the radiation pattern of a dipole antenna. So in fact, dipole antenna, they actually radiate the strongest, which is perpendicular to the wire, and weakest at the end. What does this actually mean? Let's take a look on these two diagrams in order to understand better. Okay, so you can see from here, this is actually the dipole antenna. This is also the dipole antenna in the coordination of X, Y, Z. Okay, so let me illustrate this in order for you to understand better. So this is what I mentioned earlier on. Dipole antenna, they radiate the strongest perpendicular to the wire. As you can see that this is actually perpendicular to the wire, and in fact, you can see that they actually radiate the strongest at the perpendicular to the wire. On the other hand, they are actually the weakest at the end of the antenna. As you can see over here, they basically will not be able to radiate much. So therefore, at the end of the antenna, they are actually at the weakest point. So think of this radiation shape like a donut around the antenna. Okay, so imagine this. Okay, so basically how we can actually obtain the donut shape, you take a look from the top, you look down. Okay, basically this thing is basically just one part. I actually cut them into one part, but you can imagine that this thing will be like a whole so-called full donut. Okay, right in the middle will be a hole. Okay, because this is actually the dipole antenna. Okay, so therefore, as I mentioned earlier on, they are actually at the weakest at the end over here. So therefore, there is actually a hole right on top over here. So therefore, with this, you probably can visualize the dipole antenna radiation pattern, in fact, look like a donut when we actually look at this top view over here. Before I go in-depth discussion how a dipole antenna actually work, I need your help, guys. If you had learned something from this video, appreciate you can help me by like this video. Again, okay, so if you want to support me, you can consider to subscribe to this channel and turn on your notification bell. Once again, thank you so much for strong support. Next objective, let me explain step by step how a dipole antenna actually works. Okay, so first thing will be how RF signal is actually applied to the antenna. As you can see from here, this is basically the source of the RF signal. A radio transmitter actually send an alternating current. Okay, basically from the transmitter, they actually send this AC radio frequency signal to the antenna. Usually, this is actually a coaxial cable. The signal actually enters the center feed point. Okay, so basically the signal actually enter through the center feed point of the dipole antenna. One side basically will receive the positive voltage. The other side will receive the negative voltage. With this actually create a time vary current in the two metal arms. So this is the first step how a dipole antenna actually works. Next, current flows along the two arms. Okay, so these are in fact the two arms. Like I mentioned earlier on, these are the two conducting materials of dipole antenna. Let's take a look on this diagram to understand better. Okay, because the signal is actually altering, electron actually move back and forth along each metal arm. As you can see from here, this is actually the direction of the current flow. You can see that the current flow forward and back for this arm of conducting material. Same for the other arm of conducting material. As you can see that current actually flow to and fro. And because the source is actually altering, and therefore current actually flow in two complete different directions. Basically, the direction of current actually reverse many times per second. Let's say this is for radio frequency is in terms of millions of times per second. This movement of charge actually produce changing electric and magnetic field around the antenna. As you can see from here, the electric field is in green, the magnetic field is in red, and because of the altering source, the electric and magnetic field also altering around the antenna. Oscillating electric and magnetic field actually forms. Okay, so whenever current change, this is what I illustrate on my previous page. The current, the magnitude of the current actually change. Because of this actually create electromagnetic field, as you can see from this diagram here. Two field actually appeared. Electric field, okay, basically caused by the voltage between the two arms. Magnetic field actually caused by the current flow through the wire. As you can see from this diagram here, E, which is the electric field, cross the magnetic field. This will give you the direction of propagation, as you can see from this diagram here. This field actually expand outward from the antenna, and this is how, with the changing of electric field and magnetic field, this is how they release the EM energy into the air. Field detach and form electromagnetic wave. Close to the antenna, the field are in fact attached to the conductor. But as the current keep oscillating, the electric and magnetic field, they start to support each other, and thereafter they actually detach from the antenna. So this in fact form the self-propagating electromagnetic wave that actually travel through space at the speed of the light. This is the radio signal being transmitted. This is actually a slower version, okay, with the changing of electric field and the magnetic field. You can see that they actually release the EM energy into one direction, which means that they actually propagate at this direction. So this is actually how dipole antenna actually release the EM wave into the air. This is what I showed it to you earlier on the antenna radiation pattern. Probably just now you still a little bit blur, okay, but now hopefully with this you are more clear. Let me just further explain on this radiation pattern. The energy actually radiate outward. Okay, so basically this is what I mentioned earlier on. They actually radiate outward. So the radiate energy spread outward, mainly perpendicular to the antenna, which I have illustrated earlier on. They basically radiate highest, okay, which is perpendicular to the antenna. The radiation pattern in fact look like a donut, okay, around the antenna, as I illustrate. When you actually look at this top direction here, this in fact look like a donut. So this is only just one section. Imagine that another section, okay, basically you will be able to see a donut when you actually look from the top. So as I mentioned earlier on, they actually has the maximum radiation to the side of the antenna. As you can see from here, to the side of antenna, they probably has the maximum radiation, while they have the minimum radiation along the antenna axis, as I illustrate earlier on. So this actually explains the dipole antenna radiation pattern. This will be my last slide for today's presentation on dipole antenna. Let me share a quick summary what we have learned. A dipole antenna work by, firstly, the RF current actually enter the antenna into the two conducting material, which I showed it to you earlier on. The electrons actually oscillate in the two arms. Oscillating electric and magnetic field actually form. This field actually detach and become electromagnetic wave, and this is how the wave actually radiate into the space. So this is what I have for you for this dipole antenna. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.